A person standing on the top of a cliff 171 feet high has to throw a packet to his friend standing on the ground 220 feet horizontally away. If he throws the packet directly aiming at the friend with a speed of 15 feet per second, how short will the packet fall? So the first thing that we do is we draw a diagrammatic representation of this particular problem. So I am marking one person over here who is standing on top of the cliff, which is 171 feet height, and the friend is standing at a distance of 228 feet distance somewhere over here on the ground. Now the particle is projected with a speed of 15 feet per second. 1 minute. Now the question is saying that the particle is aimed directly at his friend. So I am drawing a line joining him and his friend. So this is the aim angle which he is using. So he projected the particle with 15 feet per second directly aiming at his friend. So we are considering this angle as theta. So eventually we will get this as theta. How short will the packet fall? So now what will happen? The packet will follow a projectile path like this and will end up somewhere here, and it will fall short by a distance x. So this can be written as 228 minus x. So now if we use the concept of the two-dimensional motion, so I am considering this as x-axis and this one as y-axis. So if I write the motion along x-axis, so the first thing that we do is we try to measure this angle. So by writing tan theta, which is equal to 171 upon 228, we obtain theta as 37 degree. So once we have the value of theta equal to 37 degree, so I can write that the initial velocity along x-axis is equal to u cos theta, that is 15 cos 37 degree, and we get value equal to 12 feet per second. Similarly, we do the calculation for along y-axis. So I write that along y-axis the value is equal to minus u sin theta, and if I put the value that is minus 15 and sine 37 degree, so we obtain value equal to minus 9 feet per second. Now the acceleration along x-axis is 0, and along y-axis acceleration is equal to minus 32 feet per second square. The displacement along y-axis is equal to minus 171 feet, that is the total distance between the point of throwing and the ground, and displacement along x-axis can be written as 228 minus x. So we connect them by time, so we are taking t is equal to a variable. So the first equation that we frame is to calculate t. So if I solve along y-axis, then the equation will be displacement along y-axis is equal to ut minus half 32t square. So basically I have used the equation that displacement along y-axis is equal to initial velocity along yt plus half acceleration along yt square. So if we solve this equation, we obtain t equal to 3 seconds. Now if t is equal to 3 seconds and if we apply it for x-axis, then displacement along x is equal to initial velocity along xt. So we can write it as 228 minus x is equal to 12 into 3, that is 36, and we obtain x is equal to 192 feet. So this is the distance by which the object will fall short from the friend.